How many species of mushrooms are there?
5 million is being estimated.
Whoa.
Fungi outnumber plants 5 to 10 to 1. Not until just recently did they realize what us mycologists have known for a long time. 30% of the soil mass, when you're walking on soil, the 30% of the biological carbon is fungal. And the biggest...
Whoa. Say that again. 30%.
30% of soil is fungal mass, living and dead, of healthy soil. So, and this is the biggest repository of carbon in the world.
Wow.
In the ground is related to these fungal networks. So there is about 8.3 to about 10 million species on the planet. Right now, about half of those are fungal species. They outnumber plants up to 8 to 1, 10 to 1 by some estimates. Really nice, interesting metric. And 1 meter of a tree root, for every meter of a tree root, there's a kilometer of mycelium. Now think of that, 3 feet versus 2,200 feet. So that the extensiveness of the mycelial network in our landscapes is vast. I call it Earth's natural internet. These are membranes that are literally sensitive. I think they're sentient. They respond to every footprint that we take on this planet. And as you walk across landscapes, you're breaking wood, and that makes new nutrition available. So the competition of fungi to find that new nutrition is fierce. And so first to the menu wins. We are now understanding how essential they are for preserving biodiversity and for the health of the ecosystems as well as our own personal health. So we share more common ancestry with fungi than we do with any other kingdom.
And fungi are closer to animals than they are to plants.
Animals came from fungi.
Whoa.
You and I are actually fungal bodies.
Oof.
I'm speaking to basically another fungal body right now. So Joe Rogan, I mean, whether you know it or not, you're basically a fungal mass.
Okay.
And from a cellular point of view, under the microscope, human cells, animal cells, and fungal cells are very, very similar. We exhale carbon dioxide, we inhale oxygen.
As do fungus.
As the fungus does. We separated from fungi, basically, we chose the route to encapsulate our nutrients in a cellular sac, a stomach, digesting our nutrients within. The fungal systems digest their nutrients externally. They exhale oxygen, inhale carbon dioxide. And their network-like design allows them to respond to catastrophia. And what I mean by that is that the mycelial networks, they're so dense in the soil, and they have literally hundreds of billions of tips. And as these tips are growing out, they tend to be polynucleate at the tips, and it allows them to upregulate new enzymes, acid sequences, et cetera. So if there's a new ecological challenge, a new food source, a new toxin or something, these fungal networks are so have great plasticity in being able to code for new sequences from their DNA. So all you need is one of those hundreds of billions of tips to find a new enzyme to break down a toxin or a new food source. And what happens then is that information then is incorporated genetically into the mycelial network, and the mycelium then surges because it has new food, logically. And so when it surges and creates a new, what's called a sector of mycelium, we now know there's evidence that the mycelial network then, that it benefits from that tip exploration and discovery. So these are like massively resilient, adaptive organisms that have a network-based design, not dissimilar from that of our neural networks, not dissimilar from the computer internet. And more that I explore this, the more I'm convinced that we will find network-based organisms throughout the cosmos, probably fungal systems. And fungal systems ultimately give rise, in our case, animals, and it's more likely we'll find fungal-animal relationships all throughout the universe.